Hello everyone, I am Surendra, Master Teacher in Vedantu. I am presenting you the solutions of JEE Advanced 2019. This is question number 11 from paper 2. This question is from topic probability. The subtopic is dependent and independent events. One very important topic and interesting topic for JEE Advanced. Let us see what this question is. Let mod x denote the number of elements in the set x. Let s is equal to 1, 2, 3, 4, 5, 6 be a sample space where each element is equally likely to occur. If A and B are independent events associated with S, then the number of ordered pair A, B such that 1 less than or equal to number of elements in B less than number of elements in A equals. So let us see how to solve this question. As we are given A and B are independent, that means probability of A intersection B should be equal to probability of A into probability of B. Now the formula of probability says this will be number of elements in A intersection B upon 6 is equal to number of elements in A upon 6 into number of elements in B upon 6. So this gives one equation, that is number of elements in A into number of elements in B is equal to 6 times number of elements in A intersection B. So this is one equation which has to be satisfied for all possibilities of number of elements in A and in B. Now we are given that A has more number of elements than in B and B has to have at least one element in this. Okay, so we can make cases by taking elements in B like 1, then 2 and so on, or we can also make cases for number of elements in A. The second case, like making cases for number of elements in A, will make this bit easier. Let us see how. So number 1, I am taking A to be largest possible set. So I am taking number of element in A to be 6. In this case, A will become equal to sample space. And this equation number 1, if you check, it will be automatically satisfied. Reason being, this left hand side will be 6 times number of elements in B and right hand side will be 6 times A intersection B. But if A is sample space, then A intersection B will be nothing but B only. So you can see this equation will be satisfied for all possibilities if A has all 6 elements. So if A has 6 elements, B can have any number of elements, 1, 2, 3 up to 5, because we have to keep B smaller than A. So total cases here would be, or total ways in this case would be, number of ways of selecting A from 6 elements of sample space, 6C6 because every element is there, into we have to select B, or we can say B is a subset of S with any number of elements. So it can be written as 2 raised to the power 6 directly. But we have to subtract 6C0 and 6C6 because we cannot have 0 number of elements in B or 6 number of elements in B. So this first case here gives us answer to be 62. Okay, now coming to case 2, when number of element in A is equal to 5. In this case, from this equation number 1, we can write number of elements in B equal to 1.2 times number of elements in A intersection B. Now because A has 5 elements and B is a smaller set, so this A intersection B can have values to be either 1 or 2 or 3 or 4. It cannot have 5 because A and B then become equal. So these are the 4 possibilities. But if you notice here that even if I take A intersection B as 1 or 2 or 3 or 4, in all scenarios this value comes out to be non-integer. So if it is non-integer, there is no solution for this case. So there is no solution for this particular case when number of element A is equal to 5. So let us come to case 3, which is number of element in A is equal to 4. In this case, we can write number of element in B is equal to 1.5 times number of elements in A intersection B. Now in this case, number of elements in A intersection B can be either 1 or 2 or 3, because A has 4 elements and B should have lesser element than A. Now if we use these values, you can see only this value equal to 2 can give you integral value of B. So this will be equal to 3 in this case. So A will have 4 element, B will have 3 element, and their intersections will have 2 element. So this case is definitely possible. So in this case, if we make a diagram, it should look like this. A here, B here, their intersection has 2 elements. A has 2 other element. B also have 1 more element than these 2. And remaining 1 element will be lying outside in the sample space. So in this case, number of ways or total ways would be, first we will be selecting A in 6C4 ways. Then from these 4 elements, we need to have 2 elements common. So from these 4, we need to select which 2 will be common. And then we need 1 more element which will be selected from outside A. So into 2C1. So this comes out to be 6C4 is 15, 4C2 is 6 into 2. So this becomes 180. Let us call this as second one. Now case 4. Case 4, when number of element in A is equal to 3. In this case, from this equation number 1, number of elements in B will be equal to 2 times number of elements in A intersection B. And because number of elements in A intersection B can be 1 or 2 only, because A has 3 elements and B is a smaller set. So in this case, this will be either 2 or 4. But if we choose this equal to 2 and B becomes 4, B will be bigger set. So that is not possible. That is actually against the condition given in the question. So we will be taking number of elements in intersection of A and B as 1. Now in this case, diagram will look like this. Their intersection has 1 element. A has 3, so 2 other elements will be here. B has 2, so other element will be here, and the remaining 2 elements will be outside A and B and inside sample space. So total ways for this one will be, first we select A in 6C3 ways. Then from these 3 elements of A, we select 1 element of their intersection, 3C1 ways. Into, then we select 1 more element of B from 3 elements outside A, which is 3C1. So this becomes 20 into 3 into 3. So this also comes out to be 180. Let us call this as 3. Okay, so these are 4 cases. So there is one more case when A can have 2 elements, and in this case, number of element in B will be equal to 3 times number of elements in A intersection B. Now, if A intersection B is having even 1 element in it, then also B will be having 3 element or more elements if A intersection B has 2 elements, which means B will be bigger set. That is not possible. A intersection B cannot be taken as 0, because in that case B will also be having element equal to 0, and also if A intersection B is 0, then they becomes exclusive events which are not independent events. So this case is also giving us no solution. So you can say total number of ways, or you can say grand total number of ways to select A and B. We just have to add all those answers we have got: 62, 180 and 180. 62 plus 180 plus 180, and this comes out to be 422. So this is the final answer. Okay, so this completes my solution. I hope you like this solution. Thank you so much. Stay tuned for more solutions, more questions. Bye.